Assalamu alaikum. Okay, guys, let's continue unit 3. We already discussed this graph in very detail in the previous video. So one thing is remaining about these equations. What does it mean? It's mean that the shrinkage limit it is small. So you can see here it is small as compared to the plastic limit. Here you can see plastic limit is bigger and liquid limit is more bigger. So this equation, if it is come in the exam, so what is the series or arrangement of the limit? So this limit is the correct arrangement of the limits. You should memorize this. Remaining, we have discussed this graph in very detail in the previous video. Remaining, these are the same things which we have discussed in very detail. And what is Atterberg limit, the moisture content at which the transitions means change from one form from one to another. So it is called transition from, here you can see it is from solid to semi-solid. You have seen the table in the previous. So this is what solid stage, this is semi-solid, then it is come what plastic, and the last one is liquid. These are the stages. So we are discussing about the limits, the boundaries. These are the boundaries when the behavior of soil or clay change from solid to semi-solid. This is the boundary. So this boundary is called what? What? Shrinkage limit. Same from semi-solid to plastic. So there is a boundary. This boundary is called what? Plastic limit. And from plastic to liquid stage. So what is the boundary? This boundary is called what? Liquid limit. So this we have discussed. This is for the limit the moisture content at which the point of transition from plastic and liquid to the liquid state is called what? Liquid limit. These parameters are also known as Atterberg limit. Why it is called Atterberg limit? We have discussed because Atterberg was the scientist who described for the first time this limit. So it is called what? Consistency limit or Atterberg limits. These are the stress and strain diagrams or graphs for the solid, plastic, and liquid limits. At y-axis or horizontal axis, sorry, vertical axis, there is stress, and the horizontal axis or x-axis, there is strain. So what is strain? Stress, you already know what is stress. This is an object where the load is applied on it. So load divided by this cross-sectional area is called what? This is pressure. But the resistance shown by the material to the applied load divided by the same cross-sectional area is called what? It is stress. It is what? Load by area. So this is stress. The another one is strain. What is strain? Change in length or change in shape divided by original length. It is also called deformation. Deformation means change in the shape. So here we are simply we are dealing with the load, and here we are at axis we are dealing with the deformation. So no, when the soil it is put it in, for example, UTM or compressor machine, this is the load is applied on it. There are two plates. These are the specimen which is subjected under the axial load, compression load. So now you can see at x-axis it is still straight. There is zero strain. There is zero deformation. What does it mean? Their change, for example, it is 10 centimeter. It is still 10 centimeter, but the load it is connected with a control unit. So when we applied the load, so it will take 1 kilonewton, for example, 2 kilonewton, or maybe in psi. For example, if it is reached to 100 psi, so it is still taking the load. If it is more than 100 psi, so the change in the shape of materials is happen. So no, the change is shape is coming here, like so it is squeezed or compressed. So no, its length is here. So with change in length here, so these are the limit. Until this point, the material or the soil take the load without change in the shape. After that, you can see when even the graph is in this way, it's mean after that when the load is applied, it is still taking the load. It is still have the ability to take the load. but also with the load its shape is changed. So now you can see this is the shape change, this is the load. So there is one point, this is called ultimate limit, which is the maximum capability or maximum capacity of material or soil. Here we are dealing with the soil. It is the maximum capacity of soil which can take the load. After that, the graph comes like down. So what does it mean? The material, this is the maximum. For example, it is a strength of 100 kg. When we apply the 100 kg, so it is the maximum limit. If we increase to 110, so what's happened? The cracks will appear here. So after that, it is cracked. Once the material is cracked, or once the specimen is cracked, so what's happened? It's the ability of taking strength is become lesser. The ability of taking length is becomes lesser. So what's happened? Its shape is changed because it is broken. Its shape will be changed, but you can see shape is still changing. Here you can see this, for example, 1, 2, 3, it is 4. So shape is still changing, but you can see here the load ability is decreased. So this is the maximum point, and it is called ultimate limit or ultimate point, which have show the maximum ability of any material. So this is for the solid. So you can see for the solid side, this we have discussed very in detail in the introduction to civil engineering course, the stress strain diagram. Just for the sake of revision, I'll describe it again. So it is, you can say, a straight line here without any change. So after that, it will behave like this. Now we are looking for the material, the soil in the form of clay. So it is in the form of clay. What will happen? So there is direct, when this is clay and it is subjected to a load, a compressive load. So what's happened? This is 1 unit, and it is connected with control unit. When we apply a load on it, so it directly, for example, this is the original length L naught, sorry, L. So when the load is applied on it, so at the same time, simultaneously, the change in shapes happen. So you can see here the first is L, then it is converted to L naught, is shape and changing. So it is taking load. For example, it is start 10 psi, 15 psi. So it is still taking a load, but also change in shape. This is the ultimate point. So this is the ultimate load. For example, 100 psi, which can take. After that, the material, it will be break down. So now we are discussing for the liquid. As we know, liquid has zero ability to take the load. So this is the soil in which all the voids is filled with water, but it adopts the property of liquid. Property of liquid. What is the property of liquid? Flowability or flow. So this is the type of soil which is in the form of flow. So it's mean there is a lot of water, its volume is changed. We have discussed in the previous video in detail. So no, this soil, when this soil is subjected to a load, these are the plates and control unit. So what's happened? It has zero ability to take the load because it is in the form of liquid, and liquid have very weak. So it has a zero ability to take the load, but its position is changed, so its shape is changed. Because when the load is applied on it, so it doesn't have the ability to take the load. So what's happened? So it is shape is deformed. So its shape is changed. So now you can see it is the zero strain, zero stress. The stress is zero, but its strain is changed because its shape is changed. So these are the stress and strain diagram used for uh, shrinkage limit, plastic and liquid limit, or this type of soil. So it is important if it is come in the exam, this type of diagram. This diagram represent which limit or which stage of the soil. So you should know about this. So this is the liquid limit. Liquid limit is a key parameter of soil mechanics. It represents the moisture content in which soil transition. Soil change from plastic state to liquid state. Liquid state is the point at which soil began to flow like a liquid. This we have discussed in very detail, so you can read by yourself. So how can we evaluate, or how can we analyze that the soil, it is in which form, in which stage, it is in liquid or it is in plastic or shrinkage. So there are tests for the liquid limit. We are using the test which is called Casagrande apparatus. So we are doing the test through Casagrande. So you will see this in very detail in the practical sessions. So for the time being, you should to just know about that for the liquid limit, which test we are going to do in the labs. So its name is Casagrande. So you should memorize this. And also how many number of blows. So the number of blows to the soil. So it should be, you should to know it is 25. For the time being, you should to know these things remaining this graph. We have discussed in the class, but here the video will become longer. So we don't have a time. But inshallah, we will discuss this in very detail in the practical sessions. What is plastic limit? Plastic limit is analyzed by taking the soil clay. So you should to roll the clay if the rolling the clay if the diameter of the clay is 3 mm. If the clay crumble before 3 mm, so it is called non-plastic limit. Non-plastic limit. If the soil or if the clay is not crumbling until it is reached to 3 mm or less than 3 mm, this is the soil. You can see this is the diameter. If the diameter of the soil, here you can see if the diameter of the soil is equal to 3 mm by rolling, or less than 3 mm, maybe 2 or 1, but it is not cracked or it is not crumble, it is not breaked. So it is called plastic limit. But if it is crumble or it is cracked before 3 mm, like in 4 mm, in 5 mm, it is cracked. So it is called, it is not in the plastic limit. So we will see this in the practical session. Plasticity index, it is very important for the to find the characteristics or to know about the soil. So it is very important. It this also inshallah you will see in the next chapter for the classification of soil. So how we can classify the soil on the basis of sieve analysis as well as by the plasticity index. So it is very important term. So pay attention. There is one word index. Plasticity, you already know index. What is index means? The word index simply means a number or values that show the level, position, or you can say the coordination of something. So in engineering terms or in soil mechanics, we use the index property to describe or classify soils like Atterberg limit, specific gravity, or moisture content. For that purposes we are using. So what does mean by plastic limit here? Plastic index or PI in simply the range of water content where the soil behaves like a plastic materials, meaning it can be molded without breaking or crumbling. What does it mean? This is in simple index, it is like indicator ishara. In the cars like left, if you want to turn to the left, so you click on the indicator, so it shows indicator. So it is the indicators which tell us that how much our soil how much our soil is plastic. So through this is the indicator, or these numbers, this index give us the numbers from which we can evaluate or from which we can analyze that how much the soil is in plastic. So here you can see if the if the value of plastic index is very high, so it's mean the soil is high plasticity, usually like clay. So plasticity, as we discussed, it is usually happen in clay or in silt. At low PI, if the PI is low, so it's mean the soil is less plastic, often it is in silt. Sorry, in silt, the PI is what low, and silt for the clay, the PI is generally more. As we know that the size of 0.02 mm, this is for the clay. If the particle size is less than that, so it is wet clay. So if the size is very small, so it means the surface area is more. So the adsorb means what? The soil which is on the surface, outer surface of the particle, it is more. So when the particle is more, so they have a good attractive bond between the particles. So if the particle is small, so its bond is more. So it's mean for the value, if the pi values means high, so it's mean it is more plastic, so it shows like it is a clay. So here you can say if the pi is 0, so it's mean non-plastic. If it is between 1 to 5, slightly plastic. As we move down, If the value is more than 40, so it shows it is very high plastic, like clay. In between, you can say it is like a silt. So the plasticity index is important to classify fine-grained soil. It is fundamental to the Casagrande plastic chart, which is currently the basis for the United Classification System. And this is the formula. You should memorize this formula because it is very important for the field, as well as when you classify the soil types in the next chapter. So you should know this is plastic index. It is equal to liquid limit minus plastic limit. So plasticity index is nothing. It is the number, or it is the indicator through which we can evaluate that how much our soil is plastic. In this slide, you can see we are discussing about the plasticity chart. Casagrande in 1932 studied the relationship of the plasticity index to liquid limit of a wide variety of natural soil. On the basis of test result, he proposed a plasticity chart as shown. Casagrande in 1932, so he studied a different type of natural soils, and on the basis of these results, so they classify the soil on the different types. So at x-axis, you can see this is what it is a liquid limit, and y-axis vertically it is plasticity index. So you can calculate the plasticity liquid limit by the Casagrande apparatus and plasticity index as we seen in the previous slide, that pi is equal to liquid limit minus plastic limit. So you can evaluate these two value very easily for any soil. So once you find out these values, so there are, you can see two colors. This is light gray, this is medium gray, and this is dark gray. This is light gray with blue dots. Uh, this is medium gray with same blue dots. This is dark gray with blue dots. So these colors shows different type of soil. So you can see here this is gray. This gray means it is inorganic salt. Light little gray with high uh, little gray with little gray with the blue dots, so it shows inorganic. Medium gray, this one, so it shows inorganic silt. So you will solve the numerical problem, so then you will understand this very easily. Okay, there are two lines. There, this is called A line. This one is A line, and this is U line. So the A line separate inorganic clay from the inorganic silt. Both are inorganic, but one is clay and another one is silt. You should memorize, it is important for the exam. Inorganic clay values lies above the A line. This is A line. So above the A line, these are what? This is called what? Inorganic clay. And below it is called what? Inorganic silt. These are inorganic silt. These are inorganic clay. So the U line is approximately the upper limit of the relationship of plasticity index to the liquid limit for a currently known soil. This is the upper limit for plasticity index and liquid limit. So this is the maximum values for what? Plastic limit and liquid limit. Now we are going to try to solve one example. For the example, as we already know, the first thing is what? Given data. Given data. What is given data? Liquid limit is given here 60, and another one is plasticity index. It is how much? 10. What they need, what is required in this data, or what we are going to find. So it is soil, classify the soil. So they want to know type of soil, which type of soil is this. So after that, you should to start the solution. So in solution, as we already know, what is the value of liquid limit? It is 60. Draw a vertical line at 60. What is the value of plasticity index? It is 10. So draw a horizontal line at 10. So now this is the point, which is like the line is point out here. It is in the light gray portion. So what is light gray portion? Just go there to the table and check it. So it is inorganic silt of high compressibility and inorganic silt clay. So this is your result. Now we are going to solve the another one. Liquid limit is how much? 40. Plastic limit is 20. So here it is like in the light gray with dotted. So I think this one, yes, this one, the light gray with dotted. So this is our type inorganic clay of high, sorry, of medium plasticity. Sorry, this is for the This one light gray with dot. So this is our one medium gray with blue dotted. So it is which inorganic layer of medium plasticity. So this is the end of the chapter. Inshallah, we will see in the next chapter, Unit 4, classification of site. Stay tuned. Assalamu alaikum.